Hey everyone, welcome to TechXOps. If you are just starting your machine learning journey, this video is for you. Today we are going to explore something that's becoming a must-know for anyone who wants to build real-world ML systems. It's called MLOps. So without wasting much time, let's jump right in. Let's start with the basics first. MLOps stands for Machine Learning Operations. Think of it like DevOps, but instead of deploying apps or websites, you are deploying machine learning models. It is a set of practices that helps teams deploy, monitor, maintain, and scale ML models. Think of MLOps as the bridge that connects your experiment to the real world. It brings together three worlds: machine learning, DevOps, and DataOps. So MLOps is a combination of all of these three worlds, and together they help you move ML models from research to production reliably and repeatedly. You might be wondering, isn't this just DevOps with a new name? Not really. While MLOps borrows the mindset and automation principles of DevOps, it adds several new layers that are unique to machine learning. DevOps works well for traditional apps, but ML systems have a lot more moving parts like models, data versions, and accuracy monitoring. Let's compare them side by side. So, first feature is versioning. In DevOps, we version only the source code. But in MLOps, we version three things: code, data, and the model. Because changing any one of these changes your results as well. Next feature is your testing. So in DevOps, you run unit and integration tests. In MLOps, you still need those, but also accuracy checks, fairness validation, and bias detection. You are not just testing software, you are testing decisions made by a model here. Next is artifacts. So DevOps produces things like application binaries, as in your .jar, .exe, etc. But MLOps produces trained models, maybe your .pkl or a TensorFlow file which is .pb. So these models become the brains of your app. Now the next is monitoring. So in DevOps, you monitor logs and uptime. Uptime as in like, is your server still running or did it crashed? But in MLOps, you also need to track how your model is performing over the time, as in if it is predicting the right results or not, is its accuracy is dropping, or is it drifting, or is it making more errors than before, as in how is the quality of your response. Why is MLOps essential for ML systems? Because ML models degrade over time. It can happen due to data drift. So, data drift is when the input data distribution changes, and the second reason can be concept drift. So, concept drift is when the relationship between input and output changes. So, without MLOps, you will deploy a model that slowly becomes wrong and potentially harmful. Before we dive deeper, let's look at the ML lifecycle. So, first we collect the data, then we clean and pre-process this data. Afterwards, we do train our machine learning model using this data, and then this model is evaluated. If it passes the evaluation, then this model is deployed into production, and then it is monitored regularly. If it starts performing poorly later on, then we retrain it with the newer data. So this life cycle, as you can see, is not linear like any traditional app. Rather, it is a loop, and the MLOps approach helps keep this loop healthy and flowing. There are five key pillars of MLOps that supports this ML lifecycle loop. First is CI/CD. So this is automating the process of model training, testing, and deployment. Next, we have workflow automation. So instead of manually retraining models, we build pipelines that handle it automatically. Third is versioning. Just like Git tracks code, we also need to version our data, code, and models so we know exactly what was used to train what. Fourth is testing and validation. This ensures that models are not only accurate but also fair, unbiased, and safe to use. And the last, not the least, is monitoring. So once a model is live, we continuously track its performance and behavior to catch issues early. So these pillars together turn ML projects into real and maintainable products. Here are some of the popular tools used in each stage of MLOps. So for versioning, here you can use Git for code and DVC for data. Then for tracking, you can use MLflow or weight and biases. For automation, you can use Airflow or Kubeflow. For deployment, you can use Docker and Fast API or Kserve. For monitoring, you can use Prometheus and Grafana. So you can start small, pick one or two tools that fit your workflow, and then grow from there. Let's go through some of the benefits of MLOps. MLOps brings the same discipline to ML that DevOps brought to software. It provides continuous improvement through monitoring and retraining. It provides scalability, as in like it can train, deploy, and manage multiple models. It provides faster time to market, like it will help you to take your experimentation that you have done into your local machine into production quickly. It provides easier debugging with full version control. It provides reliability, as in like it monitors and fixes issues before users notice. Let's take a real world use case. What if an online store wants to recommend trending products? So they will use customer behavior data, then they will train their model, let's say weekly, onto this data. Then the new predictions will go live on the website, and further on, they will track which products get clicked the most. And using this feedback, they will improve their model weekly. So that's the MLOps in action here. Now let's be real, MLOps is not always easy. It could have some, challenges as well. So let's go through some of the common challenges. So first is model drift. So your model performs well at first, but as real world data evolves, it starts making bad predictions and you might not even notice it until it's too late. Then is no monitoring or alerting. So if something breaks in production, like input anomalies or prediction spikes, and no one is even watching it, so your users will suffer. Then we have poor version control. So let's say you have trained 10 versions of a model, but now you don't know which one is in production or how it was even trained. So that can cause a chaos over here. Next is slow feedback loops. So gathering label feedback or retraining can take weeks, which can eventually slow down improvement and iteration. Then we can have scaling issues. So managing one model is easy, but managing 20 models across environments with different pipelines is really a nightmare. Then we have like poor collaboration. So like as you know, data scientists build the model and engineers deploy it. But what if they are not themselves aligned? So that could break everything. Then we can have, lack of reproducibility. So you trained a great model last month, but no one can recreate it now due to missing dependencies, inconsistent code, or environment drift. But no worries, like if we have a solid MLOps strategy covering automation, observability, governance, and CI/CD, it can help us overcome all of these one step at a time. Let's go through the good practices to be followed in MLOps. First up, version everything. In software, we version only code, but in ML, we must also version training data, pre-processing code, model weights, config files, and parameters. Without this, you will never know which version produced which result. Second, automate your workflows. Don't retrain models manually or copy files by hand. Use pipeline tools instead, like Airflow or Kubeflow, to automate steps like data cleaning, training, testing, and deployment. So that way, your system becomes scalable and consistent as well. Next is integrate CI/CD. Like in DevOps, MLOps also benefits from CI/CD pipelines. These pipelines automatically test new code or models, validate them against defined thresholds, and deploy only if they pass. This helps you to avoid pushing broken models into production. Next is monitor your models in production. Watch for things like accuracy drop, data drift, latency issues, or API failures. You can set up alerts for these when things go wrong so you can catch the problems early. Next is set accuracy thresholds. So every model should have a minimum expected accuracy or business metric. If performance drops below that, then you can pause or roll it back. Next is retrain regularly. Models go stale. So whether it's weekly, monthly, or drift triggered, make sure like you train your models. So I would say here like automated retraining is the key. So this keeps your model aligned with the new data. Next is use a model registry. So keep your models organized in a model registry. You can track which ones are in development, staging, or which ones are in production. So tools like MLflow can help you here. Next is build for reproducibility. A model that can't be reproduced is a model that can't be even trusted. So you can use Docker containers, notebooks with dependencies to make your work fully reproducible. Next is keep humans in loop. So in high stake environments like in domains, healthcare or finance, don't let the model be your final decision maker. Always keep human in the loop. Finally, log everything. be it input features, predictions, anomalies, errors, just log it all. This helps with debugging, auditing, and retraining. So, these all practices form the foundation of a trustworthy MLOps. Here is how you can start your MLOps journey. Learn Git and Python. Use MLflow to track experiments. Try Docker to containerize the models. Schedule jobs with Airflow. Deploy with Fast API or Kserve, and monitor with Prometheus or Grafana. Take it one step at a time, and you will be an MLOps pro before you even know it. That's a wrap on our introduction to MLOps. If you found it helpful, please like this video and subscribe to TechXOps. I will see you in the next video. Until then, keep learning, keep building.